Hello everyone, I'm Tessin and I'm electrical engineering student. I was interning in Emertxe internship program of embedded system, and our project was microwave oven. We will completely look into what we have learned in this internship and what was our. So these are some of the topics that we have learned, and these are some of the areas that we have learned our this program. Introduction to C language. In C language, we have learned conditional statements, loops, operators, array, pointers, storage classes, preprocessor functions and strings, and many. Then our have we have wrote our code C language. Then XC8 compiler, which is used by MPLAB ID. Then PICSIMLAB, it is basically software on which many microcontrollers are present, and it is basically used for simulation purpose, for implementation of any code. Introduction to various paraphilers of PIC 16F8778. This was our target, our main microcontroller that we have used, and we have explored its function, its block diagram, its the part, whatever the parts it has, like it has matrix keypad, it has CLCD, it has ISR, interrupt, then timer, then many other codes, LEDs. Then we have also given some of the quizzes, as well as we have attended the Disha workshop, which was very informative workshop. Next, moving on, these are some of the contents that I will cover in this our presentation. Embedded system, microwave oven, requirement, and rest. Next, what is embedded system? So let me use my laser. So it is a combination of hardware and software, and it is designed for a specific task, for a specific function. The embedded computer or system has a software as well as a hardware. It linked to other systems also, and it can be used user interface. So we give input to it, and it gives output. So embedded system may also function within a large system. The systems can be programmable and have a fixed functionality. So what are the examples of embedded systems? So there are many examples of embedded system in our daily life. We will look into the few, like automobiles, that includes cars. This comes in mobile embedded system type. Driverless cars have included both hardware as well as software, and it is but examples of embedded system in our daily life, like router, like automated washing machine, and there are many more examples. Next, what microwave oven? What is a microwave oven? So microwave oven is the embedded system on which we will look into, and we will consider in our this internship. So microwave oven, it is a relatively small box-like oven that heats and cooks food by exposing it to electromagnetic radiation in the microwave frequency. So it is a box-like oven. What is the purpose of microwave oven? It reheats the cooked food, and it also cooks a variety of foods. We use a microwave oven in our daily life, so we are very much familiar with it. So, don't we? I guess we all are using it, so it's very important for us to look into the modes, and to look into the embedded system, this embedded system. So there are many modes, several modes in which microwave oven operate. But in this particular project, in this embedded project, we will focus only on four modes. Number one, micro mode. Number two, grid mode. Number three, convection mode. Number four, start mode. Now, um, let's look into each. Let's discuss each one by one. So in micro mode, it works like exactly the same way our oven works. It requires 900 watts power, and we can set a time um, and then by our own self. Grill mode, it is used for grilling purpose. Its function is same as micro mode, but it is used to cook meat and bread. Next, we have convection mode. So convection mode, we can set the temperature, and after it will be preheating for 3 minutes, and then we can set the time, and accordingly we can cook food whatever we want. And start mode, we will discuss it further in our we will discuss it further in our simulation part in PICSIMLAB. The requirements of this project are MPLAB XIDE, which is a software for writing the code, XC8 compiler. It is a compiler used by MPLAB, then PICSIMLAB, it is software. This PIC16F87778 is a microcontroller on which we work. 1646 CLCD. We will discuss all these: CLCD, timer, tactile switch, matrix, keypad, ISR. So this is the very simple and general block diagram of microcontroller that we are using, that is PIC16F8778. We have a CPU, and through CPU, through data, these are the data bus. So it has 8-bit data bus. We have fast block, serial ports, analog to digital converter, input output port ABC. Next, what is PICSIMLAB? PICSIMLAB is a software that contains many microcontrollers. It is basically used for simulation purpose. It has microcontroller like we are using PIC16F. This it also contains Arduino and many others. It is a clock, megahertz, 20 megahertz we have chosen here. This is LCD. So in there are two options, 16 cross 4 and 16 cross 2. We are using 16 cross 4 in this project. And now if we look into PIC16F877A, it has a this LCD display. It has LEDs. It has matrix keypad. This is matrix keypad. It has a relay. These are the relays. This is cooler, heater, buzzer. This is the chip. Now, what is CLCD? CLCD is character liquid crystal display. It can display letters, capitals and non-capitals, and numbers and punctuations. You can find this type of display in the products such as vending machine, 3D printer, and data logger. This is CLCD. So whatever I will type here, whatever I will click here, it will come here, or whatever I have written in my code, it will come here. Next, what is the timer? Timer is an important application in any embedded system, which is a default peripheral which maintains the timing of an operation in sync with the system clock or an external clock. It has many applications such as measuring time and generating delay. So we have always heard that a timer is used whenever a clock is generated, whenever some delay is needed. So timer counter is a software designed to count the time interval between the events. Resolution, which is also called registration bit, which can be of 8-bit or 16-bit. So time is referred as change from one number to another. It may be up count or down count. So whenever a tick will come, whenever an event will come, it depends on the quantum, which depends on the system clock setting. And the scaling, the up counting or down counting, it can be pre-scaler or post-scaler. Then we have a tactile switch. So these are the switches that are placed in PIC Genesis board, which has PIC16F877 microcontroller. It is present in many PCBs you must have seen it, and these are the small switches. And why it is used? So these are used to So tactile switches that are placed on PCBs, and they are used to close a electrical circuit. So when a button is pressed, switch turn on and the PCB works, operates, and when it is released, the switch turn off. So it is a tactile switch is a switch whose operation is perceptible by touch. So through touching, we can control its operation. Next, we have a matrix keypad, and it is a keypad in which number of tactile switches are present in rows and columns, and they are used when there is a greater number of inputs are required and still want to save some controller input output lines, and these are used in telephones, calculators. So here we have seen that this is the keypad matrix, this one. So next we have is ISR. ISR stands for Input Service Routine, and it is a service routine that the hardware invokes in response to an interrupt. It attends to the request of an interrupt resource by clearing the interrupt flag and should save register content that may be affected by the codes in the IC. It must be terminated with the instruction return. When the interrupt occurs, MPU completes the instruction being executed, then it disables global interrupt, enable and places the address from the program counter on the stack. So now I will give you the demo of implementation of our project. And thank you. These are the slides. Slides are added here. So this is our MPLAB XI IDE, and this is our project microwave oven. It is somehow merged up the C file, source files, main.c files, and source files, and .hr header files. So now we will look into our main.c file. So these are all the header files. This is the initialization function, init config, and this is our main function. If keypad matrix number 1 is click, micro mode will be on, and if 2 grill will mode will on, if P3 convection, if P4 start mode, and if P5 pause, it will pause the timer of the oven, and the oven will stop cooking, and for resuming we can choose P4, and again for stopping we can use P6, and this is all of the code, and it is so if we power on our fixing, it will show PIC6 above microcontroller, it will show powering on microwave oven, and so time is time will be shown like minute second, and the hash is used when to clear star is used to clear, and hash is used to enter. This is our H file. Now if I have to build my code, I can use software, or I can use something that's built our successfully, and this is my hex file. So now if I go to here, this is our PICSIMLAB screen. So this is talk, and from here we have given PIC6 1687778. From here board PIC Genesis, and now in the next video we will upload our hex file and show how it